Example 3 brings us to Jim and Eden just brought their newborn daughter Maura home from the hospital and are hoping to have $200,000 in her college fund on her 18th birthday. They want to know how close to their goal investing $10,000 at 9.8% compounded quarterly on Maura's first birthday would get them. To advise Jim and Eden regarding this, we're going to find the future value of the $10,000 after 17 years. Remember, she's going to college at 18, but they're going to invest this money on her first birthday, so that only leaves 17 years. The amount of compound interest that she invests, we're going to look for the amount of compound interest that the investment earns during that time, and we're going to find the impact that this would have on their goal. So again, everyone, we are going to start everything with SERMTN. And what we're going to do in this case is we have an initial investment. We want it to be $200,000, but we're not sure if it's going to get there. So that's a question mark, what the future value is going to be. The amount that we are investing initially is $10,000. The rate is 9.8%, so 0.098. And quarterly, so 4 times per year. And again, this would last for 17 years. And so I is R divided by M, N is M times T. R over M is 0.098 over M, which is 4. And M times T is 4 times 17. So 4 times 17 is 68. And then 0.098 divided by 4 I have a lot of tabs open, everyone. We'll get us 0.0245. So again, to put this in the formula, I could do it as a fraction, or I could convert it to a decimal like I just did. Now again, in my case, I need to go up, get my compound interest formula. We'll feed that to Wolfram. And again, if you want to copy and paste those somewhere else so it's easier for you to get them, go ahead. And again, for I could put in the fraction 0.098 over 4, or I can just put in directly 0.0245. Whichever you care to do at the time is fine. And for n, I'm going to go ahead and put in 68. So we get that in the course of those 17 years, that $10,000 is going to become 51,857. And so I will write over here on the side what I actually put in to Wolfram. So the formula itself is S equals $10,000 times 1 plus 0.0245 to the power of 68. And so that ends up being that the future value is $51,857.73. So the $10,000 grows to a value of $51,857.73. And let's go ahead and see what we were asked to do in this problem. The future value of the investment after 17 years, we got it. That's $51,857.73. The amount of compound interest that the investment earns in the 17 years. And so for part B, we're seeing how much money we made for doing nothing. That would be whatever we have at the end, $51,857.73, minus what we started with. And that puts us at $41,857.73. So the fund, or the investment, made $41,857.73 in interest. And again, this is money that these people are making for doing nothing. So what impact would this have on their goal? Well, they're about $52,000 closer. So they've got about, we know that they want to get to 200,000. They've got to come up with about 150,000 more. And so knowing this, if I was Jim and Eden's financial advisor, I might tell them, hey, you got to come up with $150,000 more, but we could set you up with an annuity, and you could only, whatever you can afford to put in there on a monthly basis, we can get set up for you. So we could set you up to put in $100 a month. And in the next section after this one, we would see how much of an impact something like that would have, because we'll be spending our time talking about annuities. But recognize that with a lump sum like this of $10,000, yes, it grew quite a bit, but it didn't get them to their goal. And what they could do to help get closer to their goal is put small amounts of money away every month, for instance, because that will also grow at a pretty impressive rate.